folks, today we're going to look at how to actually write code for your Circuit Playground Express. I'm going to break this down into three parts. We'll look at blinking an LED with a button, and then toggling a NeoPixel with the other button, and then using the switch to trigger a NeoPixel animation. And along the way, I'm going to go over the fundamentals of coding and then some debugging stuff too. That said, I'm going to go incredibly slow with the coding part of this. So if you have some familiarity with code, this might be too slow for you and you might want to skip ahead or put me on fast playback mode so you can get to the parts that you need that are maybe more specific to programming for physical computing. If you haven't programmed much before, this should be a pretty good introduction to some of the core principles of that. Where you should be already, you should have Arduino installed. You should have run the Blink demo from the readings on your board just to make sure that everything on that regard is set up and working. You should have the libraries installed, the board manager set up, all that. So once you have all that set up, then we can start coding. So the first thing that I want to do is that turning the LED on and off with the button. So there's two momentary buttons on here, the A and B, or the left and right buttons, and there's the one LED here that we have access to that's on pin 13. And if we look at these buttons, they're on pins 4 and 5. So I want this first button to turn that LED on when the button is pressed. So these are momentary buttons, which means that they they connect the terminals of the button while it's being pressed, and then they release those terminals when you release the button. It's not like a toggle button. We'll look at that next. But they're connected when I push and then disconnected when I release. So I just want this LED to turn on when I push the button, and when I release the button I want it to go off. So the LED gives me basically the status of that button, whether it's pressed or not. Alright, so for my code, we've got like three areas of the code here. There's the initiation zone at the very top where we'll load libraries and variables. There's the setup. This is the part of the code that runs once, and then the loop that runs forever after the setup runs. And what I like to do is, with comments, kind of sketch out what I need for my code first before I begin writing it. So I'm going to put a comment up here that's for my libraries. I'm also going to add a comment at the top here that says that the code by Matthew Mosier, so you might put your name and the date up here. We'll put 2020. Then let's see here, and then also I might have some variables there. We'll come back to that. Then in the setup, I know I'm going to have to initialize my pins for the switch and the LED, right? I have to tell the Arduino what pin mode to use for which pins, whether I want them to be inputs or outputs. So I'm going to initialize my pins in the setup, and then in the loop I'm going to check if the button A is pressed, and then I want to turn on the LED while pressed and turn it off when it's not pressed. I might add that too. Okay. So that's a sketch of what I want to do with my code in plain English. So let's go through and do that. So working with the Circuit Playground Express, I'm going to want to use the library that goes with this board. So the first thing I'm going to do is go to Sketch, Include, Library, and then down towards the bottom I've got Recommended Libraries, Adafruit Circuit Playground. And that will throw these two Circuit Playground libraries at the very top. So I might move my comment then up above there. For my pins, to set the mode of a pin to be input or output, I use a function called pin mode, and then I can give it a pin number and tell it whether I want it to be input or output. So for instance, that LED, if we look at the LED on here, it says D13. So that's the digital pin 13 is the LED. So I could say pin mode 13 output, semicolon. So that's telling the Arduino, make that pin an output. And then I'm going to go pin mode. And if I look at the switcher, it's D4. I'm going to say 4 input. And if we remember from the reference for this, these buttons specifically have a pull down resistor. Which means that the default current draw across that button terminal is to ground. So it's going to read as 0 normally, and then when it's connected, it's going to give us a 1. That is different from most of the other pins. On the outside of the board, they have pull up resistors. They will read as 1 under normal conditions, and then contact with them will short them to ground, so you get a 0. So I've mentioned that specifically because that is a difference between the Circuit Playground Express and some other microprocessors. Oops. Sorry about that. Okay, so those are the two pins that we'll need. And so I might add some comments in here, like this is my LED, and this is button A. All right. Then let's see, how do I check if the button is pressed? Well, to do that, I'm going to use a conditional statement, an if statement. I'm going to say if, I'm going to run another function here. I'm going to say digital read, so read the value of a digital pin. I'm going to say pin 4 again. I don't need to give it an input or output. I just want it to read that value, and if that is equal to 1. And I use 2 equal signs. In code, if I use 1 equal sign, I'm setting the value of a variable, and we'll see that in a minute. But if I'm doing a comparison, I use 2 equal signs. So I'm checking, is this value the same as this value 1? And if that's true, then it's going to do this stuff, in which case I want that to be this, turn on the LED. And for that, to turn on the LED, I'm going to use a similar command. I'm going to say digital write. The LED pin is 13. And this time I am going to use a comma and give it an argument, which is high. So we want that to be high. We want to turn it on versus low, which would be off. We're sending that digital voltage signal high, and that will turn the LED on. So now I'm going to, at this point, I've got something that I could try to run, so I'm gonna try it. And this is what I'll do when I'm writing code, is I will, as soon as I've got something that's like an incremental improvement, I'm gonna upload it to the board and test it to make sure that I'm going in the right direction. I don't want to write all my code and then try to do all the debugging at once because it will get too complicated. So the first thing I can do is use this check mark here to verify my code. And this will ask me to save the code. So I'm going to say 3602 Arduino digital demo 2. I guess it's really digital demo 1. Save that. Okay, there we go. And it's going to compile the code. So it's taking the code that we've written and turning it into code that the Circuit Playground can understand, and it will give us some information if it works. It'll say the sketch uses 11% of the program storage space, and the variables we have use 13% of dynamic memory. That's interesting because I haven't declared any global variables, but these libraries do. So that's where that is coming from. That's all fine. My code checked out. I didn't have any bugs. That's great. So I can try to upload it. So to upload it, I'm going to connect my USB cord here to my board. Let's see if I can get that to stay in the camera frame. Okay. And I hit the upload button. And you'll see the NeoPixel go from red to green. And I'll get some messages down here. It'll show me the writing progress, and then verification, and then CPU reset when it's done. That's if it works. This is what I'll get. I've noticed the Circuit Playground, sometimes the upload is not smooth for whatever reason, and I have a separate video on how you can fix that if you have an upload error. But now my board is on. I'm going to check this button. I'm going to push it, and the LED comes on. But when I release, the LED stays on. Okay. That's not exactly what I want. It's getting there. If I push it again, nothing. So once the LED is on, it's on forever. So we need to add an off state, obviously. But I'm noticing a kind of flaw in my code, which is that I'm using these pin numbers here, 4 and 13, repeatedly, and those are kind of nondescript, right? Like I know that 13 is the LED and 4 is the button because I've got the board here, but someone else looking at this code, we could make this a little friendlier. And so what you'll see often is the use of variables to declare the different pins, right? So in my variable section at the top, which is a global area of the code, so any variables I declare here can be used in setup, can be used in loop. They're accessible. The scope is like the largest scope you can have. So I'm going to say int for integer, and then the variable name. So I might say like LED pin, and then equals, and then I give it a value, 13. So Arduino is based in C, which is a strongly typed language. So I have to declare what my variable is going to be. Is it an integer? Is it a floating point number? Is it a Boolean? Is it going to be a string? The compiler needs to know what data to expect in that variable space. So I'm telling it it's an int. I'm giving it a name, LED pin. That I can use any kind of names that I want, so long as they're not keywords for other things, right? Like I can't have a variable named setup because setup is a function. Okay, so I have to be mindful of those kinds of things. And the IDE here should be helpful in this regard, in that it's going to color the predefined words for you, right? So if you see something turn green or orange or blue, then that's not a name that you can use. And they are case sensitive, so LED pin is not the same as LED pin. Those are different names. All right, so I'm saying we've got an integer LED pin. We're naming that 13. So then I could go through here and say LED pin, LED pin, right? And if I go verify this, still works. Um, what is this? It's giving me a very long message about the library. Fine. So that works. You'll see this. This is very common to see in Arduino code, is declaring names of pins. If I wanted to take this a step further, this int is a dynamic variable, right? So I could, for instance, accidentally say something down here in my loop like LED pin equals LED pin plus 1. That would be very problematic, because now my LED pin, after going through the loop once, is going to be number 14, and it's going to come by and check and try to turn on the LED on pin 14 perhaps. There is no LED on pin 14. So for my pin variables, then I might add a keyword const here. So that's saying make this a constant variable of integer type named LED pin equal to 13. And now I can't change it. Now that plus 1 won't do anything. So that's a way to protect my pin declarations. Now, conveniently, all of this said, conveniently with this library, there are included some names for the pins that are used by the Circuit Playground Express. So this is not actually named LED pin, it's named, what is it named? It's named cplay underscore red LED. Okay, and I'm going to put that down here as well. cplay underscore red LED. And you'll see now if I verify this, it still is fine. That works because that constant cplay underscore LED pin equals 13 is not here, but in these library header files. Okay. Just as an example, if let's say I forgot to do this, and I still had that LED pin there, and I go to verify this, I'll get an error. Arduino will show me where the error is, and it's going to say LED pin was not declared in this scope, which means that within this if statement, nothing has been declared with this name, right? And if I look through here, and if I look up here, or then in my global variables, that's right. There is no variable named LED pin, and so that's what it's telling me. So this is a common error you'll get because maybe you had a variable LED pin, or for instance, I might have C play hyphen red LED, and I try to verify that, I'm going to get this error. cplay was not declared in this scope. There's two errors there. One, hyphen is minus. It's trying to do a mathematical calculation between two variables, cplay and red LED. So I can't use that in a variable name. But also, that's not declared anywhere either, right? I meant to do underscore. So spelling and like those grammatical, syntactical errors are very common ways to get these errors, but the IDE is pretty good at identifying exactly where they are and what you need to do to fix them. Okay. The other common error while we're talking about it, right, is forgetting semicolons. So if I do this, and it's going to give me an error on the line below where the actual error is, right? Because it sees this and it's like, I wasn't expecting that close bracket. I was expecting a semicolon before that happened. So it's saying somewhere before this, and it's usually like immediately before this, you're missing a semicolon. So you can go back, look one line up, and that's usually where you need to add it. Okay, so we are good. We've got our cplay red LED. You may not be surprised to find that there's also a variable for the button A, but it's called left button. So cplay left button, and then cplay left button. And again, we're doing all of this to make the code easier to read. And to make our code more consistent, right? Because now, if we're changing, let's say we decide, oh, we actually want that LED to be on pin 15, right? We're going to do some wiring here. We're going to use the breadboard. We want to change it to pin 15. Then we could go into our library or into our variables and change that 15 in one place from 13 to 15, and that will immediately update all of our code, right? Because this is referencing something in the library. That's beautiful, and that's going to save us a lot of time in debugging problems later. So anywhere you can use variables for your pins, you want to do that, or numbers that you want to like avoid having numbers written directly in the code. This is okay, and we'll look at a shortcut for this later too, because we're using the 0 and the 1 as like on or off. Okay, so if the button is pressed, turn the LED on, then else, right? So we want another state. So if it's true, it's going to turn it on, but we want, if it's not true, what's it going to do? So we say else, do something else, and that's going to be turn the LED off. And so for this, I'm going to say digital write cplay red LED low. So I'm going to write a low voltage to the LED pin, which will turn it off. And let's upload that. If I just hit the upload button, it's going to do the verification step first, and then try the upload. So I don't necessarily have to click this button every time I do an upload. Aha, and I might have an opportunity here. Okay, yeah, good. So here we go. An error occurred uploading to the sketch, and you'll see my green LEDs on the NeoPixels are still on. What do I do? It's a weird problem to have. I'm not sure why that's happening, but to fix it, the reset button in the middle, I'm going to double click, which you'll cycle the NeoPixels and the bootloader really on the board, and then I'm just going to try uploading again. Great. Oops. And I'm going to try this, push this button, and that LED is on. I release the button, and it goes off. Push it, on, release, it goes off. So that's doing exactly what I want it to do. That's great. Other thing I want to show you that can be helpful is how we can look at some of the data that's coming off of that Arduino. Because what might not be as intuitive about this is how often we are telling it to turn the LED on and off, which is actually constantly. We're telling it to do one or the other thing. It's not a like do this once and then retain that state, right? We'll look at that later. What do I mean? Okay, so we can see some data from the Arduino. We can have the Arduino talk back to the computer if we want, using the serial connection that's in the USB jack. But we need to initialize that in our code. So it's just a couple steps. In setup, I'm going to add a comment that I need to initialize the serial connection. And to do that, I say serial.begin. And then in parentheses, I'm going to put 9600. And that's the baud rate. That's the rate of data flow between the computer and the Arduino. There's a number of different baud rates you can use. The important thing is that the computer and the Arduino have the same baud rate. So there's the initialization of the serial port. And so to show you what it's doing here, in my if, all right, so I turn it on the LED, I'm going to say serial.println, so that's print line. So it's going to be printing something with a carriage return to the serial terminal. And I'm just going to say on with quotations because that's a string. And then when I go to turn the LED off, I'm going to add a line that says serial.println off, also in quotates and parentheses. And you'll notice that the S on serial is capital S because serial is technically a class. So we've got begin, we're going to print on, and we're going to print off. And so now we'll see just how often it's actually sending these commands, right? Because every time it sends off, it's also saying digital write the LED low. Every time it sends on, it's also saying digital write LED high. Let's upload that. And then to see that, where does that on-off going to show up? Up here in the top right, there's the serial monitor. I'll click that. And you can see right away we're getting this constant string of offs. If I clear this output, it immediately fills up with offs again. So now if I go and click this button, on, it immediately is giving me, it's giving me like hundreds if not thousands of ons every second. Off, on, off, on, off. So it's working very fast. It's doing exactly what I want, but it's actually sending these digital writes constantly to the board, okay? So this is something important to keep in mind when thinking about how the commands are flowing from the Arduino to the pins in terms of the results you're expecting. And we'll see other examples where this may not be the ideal situation, right? Like you may not want to get this constant stream of data because it might cause flickering or some other weird issues. But that's it for using one of the momentary buttons to momentarily turn on and off one of the LEDs on the circuit playground.